Let's start for E. Okay. From a finite sample, events A and B are mutually exclusive. Shade the collection A or B or C. What does it mean, mutually exclusive? Mutually exclusive means what? If you go back to my slides, this one, see here A and B, they share something in common. They share the outcome 2 and 4. And here they don't share anything. Which one is called mutually exclusive? The first one. Mutually exclusive means they don't share anything, which means everyone has its own outcomes exclusively for this event. Okay? When I give you this marker, I tell you this is exclusively for you. That means it's only for you. I never give it to anyone else. Don't share it with anyone else. Like that. Okay? So that's it. So that's mutually exclusive, which means they don't have anything in common. All right? The other one's called non-mutually exclusive or mutually non-exclusive. You know, it has a non somewhere in the name. Okay? So keeping this in mind, the second part here also in this lesson is where is the union part and where is the joint part? Where if I say find the probability of A or B, what does it mean A or B? A or B together, united, right? United means all of them, right? This part and this part. This is together now, the union. And here also, if you want to get the union, it will be everything here. Does it make sense? That's the union. Okay? So in this case, the probability of the union, which is the probability of A or B, is the probability of A plus the probability of B, because you just add each one. We took the union before some of the examples, like the two-way classification table. We had some of the questions, and the main idea was to add the probabilities. But in this case, there is, if you add the A and also add the B, the 2 and 4, which is the common part, is added twice, which is wrong. So that's why you need to subtract this common part. What do you call this common part? The probability of A and B, exactly. A and B. So the common part should be subtracted. Why? Because it's included one time with the A and one time with the B. And that's also happened in the two-way classification table when you had a row and a column, and then you're adding, you know, the numbers on the row and the numbers. So there was a common part, and you need to make sure you add it only one time. But because here you are forced to add it 2 times, one time you add it with the A, one time with the B, so according to the rule, you have to subtract it. So this is the general addition rule. It's called the general addition rule, which works for any 2 events you want to get the union for the probability of the union. Clear now? Any question about that? So that's just a summary of this slide. I think we can now go back to the activities. Where is it? Okay. Now, here, where is mutually exclusive? Are these mutually exclusive?
Yes.
Huh? Or this one? This is non-mutually exclusive, right? So this is a mutually exclusive. Now he wants shade A or B or C. Is this A or B or C shaded?
Yeah.
Or maybe this one? Oh, you don't have, right? Because everything else is non-mutually exclusive. For sure, this is the right answer. Any question about that? Clear? Easy? Okay. Relatively easy. Okay, for this A and B are non-mutually exclusive this time. Shade the collection A and B. Is this the one?
No.
How about this? Non-mutually exclusive means what? They share or they don't share? They actually share something in common. Are these A and B sharing something in common? Yes. So why did you say no? The question says they are non-mutually exclusive, which means they share something. The shading is A and B. A and B means what? The common part, right? This is already shaded, the common part. Here shaded what? The or. Here shaded the or, but he's looking for the and. So this should be the right answer. Yes?
If you say shade the not common part.
What do you mean the not common part?
It's not about negative.
Not the and.
So, and minus or.
Okay, so in this case, shade everything else and leave the common part. Yeah. But these are simple questions, just to make sure you understand the difference between and or, mutually exclusive and non-mutually exclusive. Okay, now this question is telling you that 47.3% of adults are female, 11.1 of adults are left-handed. So the word adults is repeated. So that means it's not the distinction. The distinction is something else. The distinction is the female versus left-handed. So that's an event. We can call it F. That's another event. We can call it L. Right? Adults are the second. Some people get confused when they see that. And now we said 4.7 are left-handed female. So that's both at the same time. Yes, and so that's left L and F. So when you read that, you should analyze carefully the question. So in this case, what does he want? He's giving me the probability of F. He's giving me the probability of L. He's giving me the probability of L and F. So he is actually looking for probability of F or L, and I just wrote a rule now that give you this.
4.7 over 11.1.
0.7.
Wait, what was the rule?
It was and.
No. The rule was for the or.
I think that was 4.
A plus B minus A.
Yes, the probability of A plus the probability of B minus the probability of the A and B. That was the rule. So accordingly, this will be the probability of F.
What was the other rule with the
This was a conditional probability. We finished that. We finished conditional probability with active laning for D. Now we're looking for active laning for. There's no word given here at all. At all. Nothing given. This is and, this is or, this is if, this is L. No given.
I think given.
The other was given. Or from, or of, something like that.
That was, I think, the probability of A given B.
Yeah, exactly. That was A given B. Here, no, there's nothing given here. It's all about the or and the addition rules. Yeah. We have a lot today. Probability of F and L. So all what you have to do is to add this number plus this number and then subtract this number. Can you do that and tell me how much?
You get 49.4.
You should do that actually. Subtract that. 537. 537. Okay, I trust you on this. Okay, 537. So 47.3 plus 11.1 minus 4.7. Of course, if you compare these two probabilities, you will divide by 100 each one, right? And that will be the final answer. Hopefully that's right. Okay, let's move on to the next one.